So I've been working at Datadog about container monitoring for a bunch of time now, and today we're going to talk about solving the container resolution with Cgroupv2. First, let's have a look at the problem we are trying to solve. Usually when you're submitting observability data, there are two main flows. Either a pull flow in which the target is known, like is acquired for discovery from an API or from configuration, and so you know your target and you know like the pod name, pod UID, and things like that. This is typically the case for Prometheus or OpenMetrics endpoints. And the other flow is a push flow where your agent or collector is exposing a port or a socket, and your application is going to send directly the data there, typically for traces, for instance. And the issue in that case is how to identify who is sending the data. And you may wonder why it's important. Actually, it's useful, very useful, because it allows the agent or the collector to automatically enrich your observability data with all this meta information like pod name, container ID, and so on, that will allow you to filter and search in your observability platform of choice later. So let's have a look at how it was done mostly in Cgroupv1. So Cgroupv1, you could, in your application container, have a look at this proc cgroup file. And in this file, among other things, you would see your full cgroup path on like the full host path. And in that path, normally you would find your container ID. So with a good regular expression, you could just extract this information and attach it alongside your observability data and send it directly to your agent or collector. And the container ID is interesting data because it's unique and it provides the best granularity that we have in containerized environments. But now if we look at Cgroupv2, things are slightly different. So Cgroupv2 was introduced a while ago, but it's like starting to be default in the major distribution only a couple of years ago, like in Ubuntu 22, Red Hat 9, Debian 11, and things like that. And now is widely adopted. And if we look at the same file with a Cgroupv2 node, what you will see is just this. So it's empty. There is nothing in there. It's just this slash. So you may wonder why. Actually, it's not directly due to Cgroupv2. It's due to cgroup namespaces that were introduced in kernel 4.6 and that allow to virtualize the cgroup hierarchy. By virtualizing, it allows to delegate part of your cgroup hierarchy to some processes and make them believe they are the root of a cgroup hierarchy. And that is useful for like rootless containers, for instance. And so with Cgroupv2 comes by default private cgroup namespaces for all containers. And thus, all containers believe they are the root of a cgroup hierarchy, and that's why you have a slash. So how do we solve this issue? Well, before diving into the solution, let's have a look at the requirements we want for this solution. The first one is we want to keep a container ID level granularity, because this is the current level of data we have, and it's the best granularity we have. The second is we don't want to add any privilege on the application side because it would change the security profile of these applications and is causing a lot of trouble. We don't want to change anything on the host because that will be adding some friction at onboarding time to add observability. And finally, in Kubernetes, we want to be compatible with the pod security standards baseline and restricted. It's mostly the same as before, but also it means that we cannot mount anything from the host in the application. And if we look at the current Cgroupv1, or what was the Cgroupv1 solution, it ticks all these boxes. It works and ticks all that. So the first solution, and the most common one that we've seen in the community, is to have a look at another file, which is proc self mountinfo. And in that file, indeed, if you look at it in some paths, you could be able to retrieve a container ID. So is that it then? Is the talk over? Well, it will be a very short talk, so no. The caveat is, actually it depends. In some cases, what you find there, it's a container ID. But in some other cases, what you find there is like a volume ID, which is the same format, but cannot be tied easily to a container ID. It depends on your container runtime and on the volumes you are mounting inside your container. So what do we do next? Well, the second solution that we thought about was to add a mutating webhook. So how would that works? Basically, this webhook would inject the pod UID through the download API plus the container name. You would send that along your observability data to your agent or collector. And at a given time, normally this resolves to a single container ID. So that solves our problem. However, this solution has two drawbacks. The first one is, obviously, it only works in Kubernetes. And the second one is, when there is a container restart, there is kind of a race between what you're, like the pods you're watching to get these container IDs and the change that is injected. So you don't know if it's like the new container or the old container just restarted that is the one is sending the data. So it's a bit less accurate, even though in most of the time it works fine. So we kept looking and we kept wondering, would there be a better, more universal way to do that? And the idea we had was, is there an information that could be a kind of a proxy information? Okay, we don't have the container ID directly anymore, but is there an information that we can easily get from within the application and that being received by an agent on the host could be mapped back to a container ID? And the first idea we had was to use the mount namespace ID. Normally, every time you run a container, it allocates a mount namespace ID for you, and many of other namespaces as well. But this ID to be read requires ptrace read capability, and we didn't want to add that as well, if possible. So the solution that we came up with is this one. Actually, if you look inside your application container at the sysfs cgroup file, this file has an inode. And if you look on the host at the same, at the full path, so similar to the one you were getting in Cgroupv2 in your proc fs cgroup file, you would see that these inodes are actually the same, because it's the same actually file or directory. So what's possible to do is to read this data, this inode number, inside your application container, so like your instrumentation library, attach it with your observability data as before, but instead of being a container ID, it's an inode. And on the agent, on the collector side, you need to mount the host sysfs cgroup. And by working this pseudo file system and the directory structure, you are going to be able to read these inodes and map to a container ID by extracting from the path, as it was done before in Cgroupv2, with the same kind of regular expression, the container ID from this path. So for us, this is kind of a silver bullet solution because it ticks all the boxes and it works in all environments out of the box. It requires for your agent or your collector to mount sysfs cgroup, but it's often already mounted because the sysfs cgroup is the source of truth for all container metrics like CPU, memory, and so on. So it's less of an issue, let's say. In the end, what did we actually implement? Well, we don't only implement that, we kept all these solutions. If we are able to find a container ID, we send it. If not, then we send the inode. In Kubernetes, we still send the pod UID and the container name in some cases. It's typically useful for runtimes that are based on VMs, in which case this inode stuff cannot work because it doesn't share the same kernel. And then it's on the receiver side that we perform the resolution based on the most accurate information we get. In terms of implementation, solution 2 can be implemented with like a webhook and a pod informer for any agent. It works well with any kind of like gateway deployments, so not necessarily with like one agent per node or one connector per node. The solution 3 is requires to have an agent in each node and to mount the sysfs cgroup. And we do have production implementation of those in our open source Datadog agent and some associated libraries with that. Yeah, and it's been used in production since early last year, and it's been working fine. And that's it. So thank you all for attending. If you have any question, feel free to come after or raise, and the feedback QR code is also there. Thank you.